Hello students, welcome to Infinite and NEET YouTube channel. Today we are going to discuss about ionic equilibrium acid-base theories. Ionic equilibrium acid-base theories. In this ionic equilibrium, there are many theories which we have to see: Arrhenius theory, Bronsted-Lowry theory and Lewis theory. So these three theories are different, one overcomes the another part. So let us define what is an acid and is a base according to individual theory. So here let us talk about Arrhenius concept. According to Arrhenius concept, an acid is a substance which furnace H plus ions into the aqueous solutions is called an Arrhenius acid. Let us say an example here: hydrogen plus ion, HA is a weak acid, it ionizes and gives H plus and A minus. So the H plus that is formed, it is hydrated and gives a H3O plus. Now according to Arrhenius theory, let us say HCl is an example. HCl ionizes to give rise H plus and Cl minus, and this H plus is going to hydrate with water molecule and gives rise H3O plus. This is hydronium ion. This Arrhenius concept is only applicable for aqueous solutions only. And also you can see the hydronium ion is also known as oxonium ion, because H2O, its formula is given as H2O N and H plus we can write. So it N number stands for one water molecule H3O plus, and 2 H3O twice, it goes like that. Let's talk about what is Arrhenius base. A base in order the other defined as OH minus ion donor in aqueous solutions. The base is a substance, let us say BOH gives rise B plus and OH minus, and this OH minus ion furnished by this substance is said to be an Arrhenius base. This Arrhenius base is OH minus ion donor in the aqueous solution. Say an example: sodium hydroxide ionizes to gives rise Na plus and OH minus. And Arrhenius concept has some drawbacks, like H plus ion donor is an acid in the aqueous solution, OH minus ion donor is a base in the aqueous solution. While it is only and only applicable for aqueous solutions and it is limited to aqueous solutions, also it does not explain the acidic behavior of some well known acidic substances like AlCl3, and dry HCl is not an exceptional. Arrhenius cannot explain the acidic nature of HCl in the vapor state. HCl is an acid, it can be explained only in aqueous solutions. Similarly, it does not explain the basic character of metallic oxides and acidic character of non-metallic oxides, and also sodium carbonate, which does not have an hydroxide group in it, but its solution is basic in nature. That's the reason why it has so many defects. So Bronsted-Lowry concept is coming to overcome the drawback of the Arrhenius theory. Arrhenius theory is only applicable for aqueous solution, whereas a Bronsted theory is applicable for any solvent including aqueous solution. So according to Bronsted-Lowry theory, acid is a substance H plus donor, we can say it's a proton donor, therefore it is said to be proton theory. And while base is a substance which is a H plus acceptor and a proton acceptor. Let us talk about NH3. It is going to take H plus from this, so that it is a base and it is an acid, to give rise NH4 plus and F minus. So a base is defined in presence of an acid is defined in presence of a base. Similarly, a reaction between ammonium ion and HF is shown here. It is a Bronsted base proton acceptor and it is an acid. When a proton is donated from it and it is going to form its conjugate base, and a base accepted a proton, it is going to give its respective acid, conjugate acid. So according to Bronsted-Lowry theory, an acid is a substance that donates a proton, while the base is a substance that accepts a proton. And in that you can say NH3 and H3O plus, you can see it is a proton donor and it is a proton acceptor. And when you go on the other side, you are going to see this is a proton donor and it is a proton acceptor. What I mean to say here in this way, an acid turns to be a base and a base turns to be an acid, and so that you are going to see a pair of acid and base. Such pair is called as conjugate acid base concept. So let us talk about, in any acid base equilibrium, both forward and reverse reactions takes place by virtue of a proton transfer. So acid 1 and a base 2 gives rise acid 2 and a base 1. इसमें acid 1 and here it is base 1 is said to be a pair of a conjugate acid base pair. You can see, when you talk about the stability, if this is the stable, the equilibrium favors more on the forward direction. If this is a stable, equilibrium favors more in the backward direction. So if you take the HF and H2O, the same example, you are going to see H3O plus and F minus is formed, and this equilibrium is a strong acid gives rise a weak base. You can say it is a weak acid and it is going to be a strong base, and it is a weak base and it is going to be a strong acid, like that. So I just want to, we can generalize that in a conjugate acid base pair, weaker is the acid and stronger is its conjugate base, and it's a very important, and this kind of technical terms are very important for NEET examination right from NCERT textbook. Dear children, note this point here. I just want to say conjugate acid base pair is a typical acid base reaction. So an acid will have a base and a base will have an acid. ये दोनों में क्या फर्क पड़ता है? So any conjugate acid base pair, simple trick, it is they differ between one H plus ion. So I just want to say here you can say HF carbonate, it is going to give carbonic acid, and F minus, in that it is acid and base, and acid 2 and base 1. Similarly, carbonic acid and base, it gives rise carbonate and water. Like that you can see various examples. Conjugate acid base pair differ only by one H plus one proton, and also the strong acid will have a weak conjugate base and a weak acid will have a strong conjugate acid. That is the mantra of the acid base theories. And also weak acid base will also have the weak conjugate base and vice versa. And reaction will always proceed in a direction from stronger acid to weaker acid. You see the direction, or from stronger base to weaker base. Weak base cannot give the strong base. A weak acid cannot give a strong acid. So this particular term is very, very important in deciding acidic and basic character even in the organic chemistry, dear children. And also amphiprotic and amphoteric species, the one which act as acid as well as base, is said to be amphiprotic substances like water and ammonia. And here HCl, H2O, H3O plus and Cl minus. Water in this case acting as a base, but in the presence of a base NH3, it is H2O acting as a base. So a substance which acting both as well as acid and a base is said to be amphiprotic substances. Example here, water and ammonia. And moving forward, Lewis concept, electronic concept. It is a formation of a dative bond. According to Lewis acid base theory, an acid is a substance which accepts a pair of electron into its vacant orbital and forms a coordinate covalent bond. You can say that it is a dative bond. And similarly, the base is a substance which donate electron pair and forms a dative bond. I just want to say formation of a dative bond from the donor to acceptor is known as a neutralization. Electron pair is acceptor is an acid, and electron pair donor, electron pair acceptor and electron pair donor. Electron pair donor is a base. You can say the electron acceptors, electron pair acceptors, they should have the vacant orbital, electron deficient compounds. And also cations like H plus and sodium plus and Fe3 plus comes under, and the species should have vacant orbital. That is the criteria to say it is a Lewis acid. Molecules with vacant orbitals like silicon, tetrachloride and sulfur dioxide. And Lewis base is a substance, as I said, it is an electron pair donor. It should have at least lone pair of electron and it should be electron rich. And any anions can act as a Lewis acid, and water, ether and alcohols are also Lewis bases. And also you can say H3BO3 is not an Arrhenius acid and it does not give H plus from its own molecule. That is very important point as far as the NEET examination part is concerned. H3BO3 is Arrhenius acid? No, it is a Lewis acid, and it is not furnishing H plus ion directly from it. Okay, it is taking from the water. H plus ion when extremely hydrated and it forms H3O plus and H7O2 plus, H7O3 plus, like that. The structure of solid HClO4 studied by X-ray, it is found to consist of H3O and ClO4 minus, as it is indicating like that. So when you talk about the relative strength of an acid, according to Arrhenius concept, a strong acid is the one which furnishes more H plus ions when it is completely ionized. Similarly, a weak acid is the substance which donate less number of H plus ions. And talking about the other examples for this, H2SO4, HBr, HI, HNO3, HClO4, these are all the strong acids. And except this, any acids that you can say phosphorus acids, organic acids are the weak acids, and the substance whose ionization is not completed and do not give complete ionization and gives less number of H plus ions is called as a weak acid. And similarly bases, the alkali metal hydroxides are strong bases, and the other metal hydroxides like D block element hydroxides and ammonia, they are going to be the weak bases. Talking about the types of acids, acids are classified as monoprotic, diprotic and polyprotic. Protic means the number of H plus ions that are donated per one molecule of an acid is known as the basicity, and it is a monobasic acid, they donate 1 H plus, and dibasic acid they donate 2 H plus, and polyprotic acid, triprotic acid, they donate 3 H plus ions. Like that, when you talk about this H3PO4, the hydrogen that is attached to oxygen only responsible for the acidic nature. Hydrogen that is attached directly to the phosphorus is not responsible for the acidic nature. So H3PO3 is a diprotic acid, and H3PO4 is a triprotic acid. Like that, the basics of the acid base theories are very important, and it is truly getting very good number of questions from connected with NCERT and NEET examination. You can say the types of bases: monoacidic base, they donate only 1 OH minus, and the diacidic base they donate 2 OH minus, and the triacidic base they donate 3 OH minus. Like that you can see, and based on this Arrhenius and Lowry, Bronsted-Lowry and Lewis theory, there are so many questions can be asked in the previous NEET examination as well. So you stick to this particular information and try to solve so many questions from any material that is available to you. And today we discussed about acid base theories. Please like and share and subscribe with it, and thank you very much. Signing off, Suresh from Infinity Lane. Thank you very much.